Good morning. Welcome to Mission Control Houston and the International Space Station Flight Control Room. This is where there's a team of specialists on duty around the clock, monitoring the operations of all the systems on the station as it orbits 250 miles overhead, just as they've been doing for more than 20 years now without a single missed day. That streak began with a rocket launch on November 20th, 1998 at the Baikonur Cosmodrome in Kazakhstan.
Main engine start, 6 engines up and running. And liftoff. Liftoff of the Proton rocket and the Zarya control module. The International Space Station is underway.
Launch of that first building block was quickly followed by the arrival of a second component. Assembly of the International Space Station in orbit was underway. 232 different human beings have been on board so far, still counting. The expedition 57 crew members from the United States, Russia, and Europe are on board now to mark this anniversary. Commander Alexander Gerst and his crewmates sent a message of congratulations to the partner space agencies and the people of the world.
I'm talking to you right now from inside the most complex machine that humanity has ever built. But it is not only that. It is also one of the most valuable and unlikely achievements of humankind. And on this very day, 20 years ago, its first part was sent out to space. It left planet Earth. If you're younger than 30 years of age, for almost every moment of your life, there was a human being in space, on the space stations Mir and ISS. 7 billion humans live on planet Earth. 3 humans live in space right now. We are from 3 different continents. We are friends. We are here for you. We are your eyes looking down on this beautiful planet. We bring home a rare perspective onto ourselves. Our eyes see things down there that otherwise remain unseen. Some good, some bad, some alarming. There was a time when some seemingly crazy optimists dreamt about this ISS project. Other people, calling themselves realists, said this was not possible. But more and more people understood the meaning of such a project and stood on the optimist sides. In their minds, a visionary spirit, despite all the doubts, and see who was right. Here we are, in the most complex machine that humanity has ever built. But this didn't just happen by itself. Humans built this with their visions and with their hands. And we could not have built it if we didn't throw international discrepancies aside and get together on a global level. More than 100,000 individuals from 16 core countries have participated in the construction, and from this project, every human on this planet can benefit. This is an achievement far greater than what a single nation could achieve alone.
Двадцатилетие Международной космической станции наш экипаж имеет честь встречать, неся космическую вахту непосредственно на ее борту. Для нас это очень почетная и ответственная миссия. МКС сейчас представляет собой ярчайший пример торжества научной мысли в сочетании с непревзойденным примером международного взаимодействия. Наш экипаж 57-й экспедиции поздравляет весь многочисленный коллектив ученых, инженеров, сотрудников предприятий и центров управления. Всех тех, кто стоял у истоков и работает в этом удивительном проекте. Всех тех, кто следит и переживает за успех космической пилотируемой программы.
The International Space Station is a unique scientific platform that enables researchers from all over the world to put their talents to work on innovative experiments. Because of our unique microgravity environment, the experiments we perform on ISS cannot be performed anywhere else on the planet. Already, more than 2,500 experiments have been conducted with over 3,000 investigators leading those experiments from over 100 countries, including those by students in multiple schools. This science is being performed in many areas, including biology and biotechnology, earth and space science, physical science, materials science, technology development and demonstration, and of course, human research. What's important to remember is that many of these experiments don't just benefit our ability to live in space, but also directly impact our lives on Earth. From improving water purification worldwide to monitoring natural disasters and even developing improved vaccines, space station science is truly off the Earth, for the Earth.
ISS is a ship that teaches us how to fly beyond the horizon. It covers the distance from the Earth to the Moon within half a day. We are literally the first generation of fish that left Earth's homely ocean. The next generation will set their foot on Mars using the knowledge and technologies developed on the International Space Station. We are proud to serve on such a ship. Всего доброго с Международной космической станции.
Мы желаем благополучия во всем, добра, мира и дальнейших успехов в достижении совместных целей на Земле и в космосе.
The International Space Station is a partnership of the space agencies of Canada, Japan, Europe, Russia, and the United States, with control centers around the world coordinated by the team here in Houston, where the program's headquartered. 20 years ago, Kurt Scheierman was one member of the NASA team working with the Russian space program on its elements of the station. And today, he's NASA's Space Station Program Manager. He spoke with my colleague Rob Navius about the history and significance of what he's seen in this program in 20 years, starting with what the partner countries and their space agencies brought to the program.
So the United States, of course, had their own spacefaring history, and Russia had their own spacefaring history, and it was really neat to see it joined up. I know we had done a couple of joint programs before, but this was a really long-term, very, very large-scale program. It was really, really interesting to see what people brought to the table. In terms of hardware, of course, the Progress and Soyuz vehicles were the staples of Russian programs before and the staples of ISS today. The core module of the Mir space station is essentially the service module of the International Space Station. On the U.S. side, we had begun the manufacture of a number of pieces. It was really more the individual hardware elements, the components that we had brought forward into the International Space Station. And of course the Space Shuttle, which was the workhorse of assembling the International Space Station, had been flying since 1981. So all these pieces together had existed before. Assembling them in a really unique spacecraft has really led to this successful program that we've had.
I think few people remember the fact that none of these modules, whether they be U.S., Russian, or international, actually were integrated ahead of time, and yet through simulations and through testing and through a lot of hard work, they all seem to come together and work together with very, very few problems. Is that not one of the hallmarks of what we're seeing up there today?
I think so. Of course, engineers tend to appreciate those kind of things, and the public maybe not as much, but the first two pieces, the Zarya module launching from Kazakhstan and the node Unity from the United States, the first time those pieces ever touched each other was 250 miles above the Earth, traveling 17,500 miles an hour. They fit together perfectly, and the electrical signals across the interface was perfect, and yet that was the first time they had ever seen each other. Really, really amazing. So we have this geographical differences, and then as the program matured, we actually had, I'll call them temporal differences. We had modules that were built and flown, and another module was built many years later and actually came up and made it, and they all work together. So really a tribute to the engineers around the world, both in the United States and Russia, Japan, ESA, and even commercial companies such as the Bigelow Company, all working together to make this thing happen.
So the milestone of 20 years of the International Space Station, not to be forgotten. We just passed the milestone of 18 years of a permanent human occupancy on the International Space Station. Pretty remarkable when you think about that in of itself. How important has that been in establishing a permanent human foothold in space for future deep space exploration?
I think it's been really very important, both from the space community in the United States and Russia, but really a thing that I'd like to touch on is more it means to the world. People now, 18 years old, have never known a time when people didn't live and work in space. They take it for granted that humans live and work in space, and yet just a generation before, everyone knew there was times when not only did humans not fly in space, nothing flew in space. So what a huge progression. We've gone from nothing in space through Sputnik, through Gagarin, through now the International Space Station. We've had people living for 18 years. So it has changed the mentality, the thought process of everyone on this planet. What a great accomplishment that is. Not to mention all the research and things we learned about, we've already learned, and we continue to learn. Even today, we're learning things about the human body we never knew existed before. It's really changing the knowledge base of the human species.
Good point there in terms of the evolution of the space station, not just as an engineering marvel, many call it the most complex machine ever built by humans, but as an international laboratory. That must be very satisfying for you.
Yeah, first of all, the fact that it's international is great. It's not the domain of any one country. Today, experiments have been run on board the International Space Station with hardware experiments, investigations that have touched over 103 countries around the world. 103 countries. So not only is it the domain of the partner countries that are involved in the ISS, researchers from across the globe have participated. So it's something that the whole world can be proud of.
We've touched on the fact that over 2 decades there have been very, very few significant technical issues that have cropped up with the space station, but when there have been technical issues, albeit few and far between, how have the U.S. and Russian sides worked together to identify them, to solve them, and to press ahead?
Sure. Cooperation, I think, is the hallmark of our work together. The United States and Russia began cooperating on ISS in 1993-94, and that cooperation is even stronger today than it was back then. But all these issues that we've had, whether it's Space Shuttle has been down for years because we had an accident, or we have just this recent launch abort on a Soyuz vehicle, we all pull together as a partnership, both the United States and Russia, but really also Japan, ESA, and Canada all pitch in and help each other through these times. So what a great partnership. In fact, I think this is the real strength when we have these issues like this. Everyone gets together, figures out what we can do to help each other out and pull through. So we've had a number of anomalies like I talked about. We've had on-orbit failures. We've had failures when all the U.S. computers failed. We have cases where all the Russian computers failed. And everyone says, how can we help? What can we do? And I think the fact that the vehicle has been on orbit for 20 years, and we've had humans on board for 18 years, is really a testament to that really strong cooperation, which I hope continues on to the future.
And in concert with that, Kirk, the legacy of this partnership in terms of global diplomacy, how critical has that been?
You know, as an observer, as a citizen of the United States, I look at the cooperation between the United States and Russia, and it's ebbed and flowed over the years. But the thing I know has remained strong is the cooperation in the space, in particular the International Space Station. I look at us, the International Space Program, as a kernel to continue to grow a very strong, lasting peace between the United States and Russia. And it's been great for these 20 years, and I expect it to be great for years to come.
And finally, in that regard, NASA and Roscosmos, how do we plan to work collectively in the future as we move into commercial crew and perhaps the Deep Space Gateway and so forth?
All right, today we're cooperating on the International Space Station. I expect that to continue on for a number of years. We've been working with our Russian partners on the Gateway, putting an outpost in the vicinity of the moon, talking about what might happen going on to Mars, going to the lunar surface. All these things we've been talking together. I expect that we'll continue those as international endeavors, that we'll be very strong partners. We have a very, very bright future, I think, together in human spaceflight.
The goals of the International Space Station are to prepare for future exploration, promote international cooperation, and enable commercial participation in spaceflight and space research, all while enabling scientific investigation in a whole range of disciplines. That includes looking at enabling experiments into how the human body responds to being in a weightless environment for an extended period of time, including specifically the immune system.
Your immune system in space. Presented by Science at NASA. Getting sick when you're far from home is a drag. You'd give anything to crawl into your own soft bed and sleep, but you're stuck in a cookie-cutter hotel room feeling like a sick fish out of water. Well, it could be worse. You could be an astronaut on the way to Mars, a really long way from mom's chicken soup. Future space travelers will need to stay healthy to perform well for their own safety and for mission success. So it's important to understand how extended space travel will affect them. The immune system works unnoticed to protect the body. But even subtle changes in that all-important system may be linked to the onset of illness. Factors like radiation, microgravity, stress, and altered sleep cycles could all affect astronaut immune systems. A new NASA study entitled Functional Immune will investigate the immune system changes that occur in International Space Station, or ISS, crew members. Understanding these immune system changes may help scientists pinpoint the onset of illness and suggest monitoring strategies or treatments that can boost the immune system and prevent full-blown infections and diseases here on Earth. Functional Immune builds upon the results of several previous NASA studies of the immune system, which, according to Johns Hopkins University scientist Dr. Mark Shellhammer, tell us there is no place during spaceflight where we see stabilization of the immune system. In 2014, NASA's Integrated Immune Study showed abnormalities can occur in immune cells in ISS crew members' blood during flight. Normally, the immune system attacks and eliminates virus-infected cells. When cell activity is depressed, the immune system isn't responding to threats as it should. When cell activity heightens, the immune system reacts excessively, which can result in illness, increased allergy symptoms, and persistent rashes. ISS crews were also observed to experience reactivation of latent viruses from childhood, a finding directly related to reduced immune function. The Integrated Immune Team, working with the NASA Nutrition Laboratory, also measured the concentration of cytokines in blood plasma, the proteins that marshal the forces to an infected or injured body site to defend against invaders. The data indicated that changes can be seen in blood cytokines just as changes can be seen in cell function. Dr. Brian Cruchon of NASA's Johnson Space Center, or JSC, principal investigator of the Functional Immune Study, says, "The immune system is very complex, and several aspects of immunity remain uninvestigated during spaceflight. We now need to delve deeper into the immune system changes that happen in space, and also determine if immune changes during flight elevate clinical risks for astronauts in future deep space missions. All the factors that change immunity on the ISS will be worse on longer missions to an asteroid or to Mars." Functional Immune includes NASA scientists and external collaborators at the Johnson Space Center Radiation Lab, the University of Houston, and the State University of New York. The study will reach beyond any previous space immune study and include exciting newer tests such as transcriptomics and proteomics. These tests will happen in parallel with the assessment of immune cells in blood, stress, and virus reactivation. Cruchon says, with the ISS, we have a unique opportunity to study very healthy people in a quasi-isolation chamber, yet experiencing all the stressors that are specific to spaceflight. Results should help clarify the influence of spaceflight-specific environmental factors on immunity and identify countermeasures to mitigate their effects. These studies could improve scientists' understanding of the immune system, making a positive impact on human health at home and while traveling both near and far. For more from the International Space Station, go to www.nasa.gov/station. For more news about spaceflight and the strange things it does to the human body, visit science.nasa.gov.
The laboratories on the International Space Station provide a setting for scientists to do experiments that take the force of gravity out of their equation, which is to say, they can do experiments here that they cannot do on Earth. For example, there's an experiment underway that's studying sediments of quartz and clay and focusing on the forces between particles that cluster together. Are just a couple of examples of laboratory science. But another top priority of the International Space Station program is enabling the commercialization of spaceflight and space research. And now, in conjunction with NASA's Commercial Crew program, the station is moving the nation closer to the goal of restoring the capability to launch astronauts to space from the USA.
Stand by for terminal count.
Stage 2, pressing for flight.
5, 4.
The purpose of the Commercial Crew program is to return to our nation the capability to fly our astronauts to the International Space Station.
Ground gas closeout very complete.
3, 2, 1.
This Commercial Crew program is the beginning, I think, of an entirely new era.
Go for launch. Side booster ignition.
Liftoff. Astronauts taking flight once more from American soil as the nation begins a new chapter of space exploration.
Stage 1 propulsion is nominal.
This is us as a nation. This is us as a NASA private-public partnership together, allowing our nation to capitalize on what they've invested in within NASA to be able to create this industry.
Both of our companies, Boeing and SpaceX, are incredibly capable companies.
It's just an awesome feeling to see the hardware coming together and seeing, the excitement of the technicians, of the engineers.
It's going to be wonderful to see the crowds come back. And this is great, to get the public kind of re-engaged on human spaceflight again.
The Commercial Crew program is revolutionary in a sense where it's going to provide us the opportunity to have more astronauts in space. It's going to further our ability for knowledge in a microgravity environment.
We need to explore, we need to pioneer, we need to see what's out there and find new places to live.
The International Space Station still has a lot to teach us.
I think we're going to have a lot more opportunity to do the exploration research that we need to get us to the moon and to Mars and beyond.
There's a larger group of us that are dreaming that potentially could have a ride someday and be working in space.
It's a huge goal, a huge accomplishment for both the partners, NASA and the United States of America.
The fact that we're able to partner with commercial industries allows us to fulfill that mission, to be explorers, because we can work together.
This is just the beginning.
I know the greatest events in space exploration have not happened yet, and that our destiny lies above us.
The International Space Station has completed 20 years in space, getting us ready for missions back to the moon and out into the solar system. Those are missions that will be flown on the Orion spacecraft. Here's a look at the current state of work as teams across America and in Europe develop and build the systems that will carry us to those future destinations. If you'd like to get another look at any of the stories we feature today, you can. Check us out on YouTube and on Facebook at the addresses right there. They're all there. And while you are there, look at all the other cool stuff you will find about NASA and America's human spaceflight program. And while you're bumping around the interwebs, check out Houston We Have a Podcast. It's folks here at NASA talking about their work in all aspects of space exploration. The new episodes post on Fridays, and this week Gary Jordan starts a two-part remembrance of the beginning of the International Space Station operations in orbit. A conversation with NASA's Zarya Launch Package manager Doug Drury talking about getting Zarya ready to fly. Go to nasa.gov/podcasts. You can find today's episode there and all of them in the series, plus the full library of all NASA podcasts. And you can also listen to all of them on Apple Podcasts, Google Podcasts, and SoundCloud. This is Mission Control, Houston.